Hi students, welcome to Math4U. In this session, I will be explaining you some more theorems which is related to fundamental theorem of arithmetic. Along with this theorem, we can prove whether a given number is irrational or not. Okay, so before going deep into the theorem, let me ask you, what is irrational numbers? You have learned in your grade 9 as well about this, right? So irrational numbers are numbers which cannot be represented, in the form of p by q where q not equal to 0. Very good. So these are called irrational numbers. So let's see what is the theorem. So in your book, it is given the theorem 1.3. That's what I'm going to explain to you now. Okay, 1.3. The theorem says let p be a prime number. If p divides a square, then p divides a when a is a positive integer. So I'm taking the prime factorization of a. Okay, so we are taking the number a, that is a positive integer. What will be the prime factorization of a? Yes, I'm going to take it as p1, p2, p3, etc. pn. Okay, so if a is equal to p1, p2, p3, etc. pn, what about a square? A square can have this much multiplied one more time, right? A into a. That is p1 square, p2 square, p3 square, etc. pn square, right? Yes. Now, okay, what can we do now? We got a and a square, right? So can we take p as a prime factor of a from here? Let p be a prime factor of a. So p is included as a prime factor of a. I will give you an example. I'm going to prime factorize the number 12. Okay, this is a positive integer. So let me do the prime factorization of this. 2 times 6, 2 times 3, 3 times 1. So what all are the factors of 12? 2, 2, 3, 1. So 2, 2, 3, 1 are the factors. Can I tell 3 is a factor of 12? Yes, correct. So can we say 3 can divide 12? That also we can say, right? So I have taken p as a prime factor of a. So can we say that p divides a square? Of course. As we have seen here, 3 can divide 12. We can say that since p is a prime factor of a, we can say that p divides a square also, right? P is a prime factor of a square, okay? P divides a square also. That means what? P can divide which number? P can divide a. So this is the conclusion of this theorem, where p divides a square means p can also divide which number? A also. So let us move on to the next theorem, that is theorem 1.4, root 2 is irrational. So how can we prove that this root 2 is irrational? This we can done under an assumption that root 2 is a rational number. Root 2 is a rational number. So let's assume a root 2 is a rational number. So if root 2 is a rational number, how can we represent it? Therefore, we are writing root 2 is equal to a by 4, b4, that is p by q4, okay, where here a and b are coprime. So let me ask you, what is coprime? Which do not have any common factor except 1, right? Yes. So I'm going to cross multiply this. That means b root 2 is equal to a. Next step, we are going to squaring. What we will get as the left hand side, b root 2 the whole square, and the right hand side becomes a square, right? So this will come as a root 2 square, that is 2. B square is b square. So 2b square is equal to a square. Okay, I hope this much is clear. So now we are taking, let a is equal to let a is equal to 2c. Okay, I'm taking a as 2c. So I have marked this 2b square is equal to a square as equation number 1. So how the equation number 1 will be changing? If a is equal to 2c, can we write it as a 2b square is equal to 2c the whole square? So a is 2c, instead of a I have substituted here 2c square. Is it correct? Yes. So we can say that this is equal to 2b square is equal to 4c square. What is a b square from this? That means b square is equal to, can you tell me? Yes, 2c square. What does this mean? This means that 2 can divide b square, right? That is 2 divides b square. So what can we say? 2 can also divide. 2 can also divide. Yes, b. So we can say that a root 2 is not a rational number. Why? Because all these got, since we took root 2 as a rational number by assumption, right? By assumption, we got all these facts. Is it clear? Is it clear to all of you? Yes. So here we can understand that this contradiction, the fact that what A and B have no common factors other than 1. Okay. And we can say that now root 2 is a rational number. Since we took the assumption that root 2 is a rational number, that's why we got as 2 can also divide B, right? So we can prove this like this, a root 2 number is rational. Okay, so let us see one question based on this, so that I hope it will be more clear to you. So the question is, proof that root 5 is a rational number. So here I'm going to take root 5 as a rational number by assumption. As we have seen, we have to take at first assuming this root 5 as a rational number. So let assume, okay, assume root 5 is rational. Okay, so we are assuming here root 5 is rational, right? So how can we write this root 5? Yes, therefore we can write it as root 5 is equal to p by q form, right? That is a by b. Here a and b have a common factor, is it? Okay, let's see how can we do this. We are assuming this a and b are coprime. So what does coprime mean? Again, I'm asking you, do not have a common factor, right? Except 1. So this one is not having a common factor except 1. So we can write a is equal to root 5b. What is a square from this? A square is equal to, yes, 5b square. Therefore, a square is divisible by what? 5. It can also divisible by which number? 5, right? Okay. So we are writing let this a is equal to 5c again. Okay, a is equal to 5c. So how can we write this equation? How can we change this equation? So we can write it as 5b square is equal to 5c square, right? 5c the whole square. That means 5b square is equal to 25c square. That means from this you can understand that b square is equal to 5c square. So this shows that a and b can have 5 as a common factor. This is easily divisible, right? So why we got like this? Because we assumed that root 5 is rational. Okay, so we can say that as a conclusion, root 5 cannot be represented, cannot be considered as a rational number. That means what root 5 is? irrational, right? Root 5 is irrational. So I hope it is clear. First, we assumed the root 5 is rational and we wrote it in the form of a by b. Then we have done the cross multiplication. A is equal to root 5b. Again, we have squared. A square is equal to 5b square. We put a is equal to 5c and we converted equation number 1 as 5b square is equal to 5c the whole square. And we got it as 25c square. From this, we got b square is equal to what? 5c square. So this shows that a and b have a common factor 5. And this is a contradiction to the fact that A and B are coprime, right? But root 5 cannot be expressed in the form of P by Q, and it can be said that root 5 is irrational. Is it clear? Yes. So let's move on to one more question. Let's do this question. Prove that 3 plus or 2 root 5 is irrational. How can we do this question? How can we do this question? How can we say that 3 plus 2 root 5 is irrational? Okay, so let us write, we are assuming as we have done the previous assume or let 3 plus 2 root 5 is irrational, okay? Therefore, we can find two integers a and b where b not equal to 0. That means I am taking 3 plus 2 root 5 will be equal to a by b where b not equal to 0. Okay, this is the format of rational number a by b or p by q. We usually use p by q, right? Okay, so from this I'm writing 2 root 5. I'm taking this 3 towards the other side. That means 2 root 5 is equal to a by b minus 3, right? Then again, what will be root 5 from this? Root 5 is equal to, can we write half of a by b minus 3? Okay, since here a and b are integers, 1 by 2 of a by b minus 3 will also be a rational number. Therefore, root 5 is rational, right? We can say that root 5 is rational. Why? How can we say so? This contradicts the facts that root 5 is irrational. Our assumption was that what? Our assumption was 3 plus 2 root 5 is irrational. That is why we got root 5 as a rational. But we assumed that, right? So we can conclude, therefore, 3 plus 2 root 5 is an irrational number. Is that clear? First, as we have done previous cases, we have to assume that it is irrational. Then we are writing it off the form that is equal to a by b. Then taking whatever it's on the left hand side to the right hand side except that root 5. So we proved that first root 5 is rational, but we took it assumed that 3 plus root 5, 2 root 5 is rational, right? Hence, we proved 3 plus 2 root 5 is irrational. Is that clear, all of you? What we have done? I hope it is very much clear. So, one question for you is you have to prove, okay, prove that root 3 is irrational. So, please try to do it and let me know whether you got it correctly. Thank you.